Alright, well, fucking recording in the car, I guess. See if we even have... I mean, we're not gonna have internet here. I can't imagine we would. Nah. Oh, it's a good long chapter, though. Good. Excuse me, so... Let's see. I'm trying to find a way to... I guess I'll just brighten it up, maybe. Oh shit. Fuck it, right? I mean, it's not going to update with battery life until a little while, I think, but let's get the glasses going and start going, huh? Cool. All right. Yeah, we have size for the length, basically the length of a container, right? And then we have, sorry, length for the length of a container, meaning how many elements are in the container. But then size is basically, I don't know if there's padding. If we assume that there isn't padding, because structs, there's padding, so if you have a large, well, let's see, if you have a small, is it large or small? Like if you have a small data type as the first data member and then a large one for the next, I think there's padding between the small data type and the large. I mean, how I conceptualize that is that we have buckets of memory, and if one type is so small that it doesn't even use up one, then there's going to be padding to fill up the rest of one before we get the next one. So the size is going to be actually bigger than how big it really needs to be, I think. Whereas if our first data member takes up an entire or multiple bytes of memory, we'll just say, I mean, byte isn't the right number because a character is 1 byte. So you would think that a struct with a character and an integer would be 5 bytes, but instead it's a different size, I think. Let me just verify that to make sure. Oops, Jesus. Hold on, I got some shit on the glasses. But the point here is that assuming that there isn't padding inside a container, then the size should be equal to the length times the size of one element, or the, what do we call it? An item? I don't know. The length times the size of one item. So if we have an array of 11 integers, an integer should be about 4 bytes at least. So we should expect about 44 bytes for an 11 integer array. So if we have character x, int y, and then we include IOStream because we need input and output. Specifically, we need standard character output because that has definitions to iStream and OStream. We can output size of a type, right? Well, only one error, and it's because we don't have a semicolon. Oops, I should have just deleted there, but it's fine. That is bad white space. Okay. Oh, this car's gonna get fucking hot, dude. Fuck, do I just update this to be this direction? Maybe. That's better. Oh, now I can see the screen too, good. Size is 8. See, there's padding. So, it's treating the character like, oh, maybe, yeah, it's not going off bytes, but it's going off the largest size object. So if we had, let's say we have an int, what if the same thing is true, but we have an int and a long? So we have long and an int. Same thing exactly. Okay. So it seems like so far the behavior is that size of is returning, well, the minimum size of a test right now is it seems like it's taking the largest data member size, which in this case is 8 bytes for y a long, and it's multiplying that by the number of members. So for example, if we have 2 longs in an int, well, it sees, okay, what's the biggest size data member? 8. Okay, how many data members? 3. 24 is the size. So let's see. Long z. Oops, no semicolon, syntax error, dumbass. Okay. And then how about is it going to be the same now if we make this a character y? Because long is still 8. It should still be 8 times 3. No, it's 16. Oh. I'm not fully sure. I was going to say that it's packaging memory into the size of the largest guy, but it's not. I'm not sure. Honestly, I'm not super sure. If we assume that there's no padding, though, then we should be fine. Fuck, I should have stayed at work, honestly. It'd been cooler and then come here. But whatever, I'll be more warm. I'll be literally warmed up, so. Size is the size of an object in terms of storage, whereas length is the size in terms of element count. With a carton, we can fill it. We can find a specific one in there and do stuff with it. We can swap them. We can remove them, put stuff in there, count the total, all these things. So there's empty. Empty, but with storage for some amount that it can hold, like a C-style array. At compile time, we pass in how many elements it can hold, and then boom. And it might be empty, or it might not. Or we can create it with a list of values, and it gets created with that size in mind. And apparently, standard vector has the dynamic ability to grow and shrink and delete unused elements. You can access elements, get a specific element, get the first, get the last, get any other. So we could get the size -1 to get the actual index, because of 0 being the off by 1. We can insert, so like adding a new one and then removing it, so it could go from length 15 to 14 and 14 to 15. Get the total, which could just be length. Others, like sorting or... Okay. Can I improve this even more? Oh shit, yeah. So one language, oh gotcha, meaning not the language, the container type. So one container type and operation might be more efficient than the same operation in another. I think in Unreal at least there's a name type of object, and you can assign a name to something, and the name apparently can't be changed while a string can, yet a name is apparently cheaper to iterate through and compared to another string, or to another name, compared to a string being evaluated and compared to another name. Basically, it's less efficient to iterate through a string, compared to iterating through a name. So I could see that. Maybe name is a vector in Unreal Engine's wrapper compared to a string. Gotcha. So pluses and minuses. The reason it's fast is because it doesn't have to check to see if it has changed its length or something like this. Only access elements in sequential order. What do you mean? Like you can only access one and then the next and then the next? And what, do you have to keep accessing until the end before you can get back to the beginning? I don't know what you mean. Makes sense. Okay. Yeah, learn the container types, basically. Element types. Containers are homogeneous, so meaning, I'm assuming, the same element type for the entire container. Yeah, elements of the container are required to have the same type. In most containers, all containers are apparently homogeneous, so there's no container of, oh, in element 3 is a string, element 4 is a character, etc. But then that's an array of strings. But it got hot. The camera's working. Some containers have a preset one, meaning a string has gotcha. So it's already a type. Whereas, I mean, it's probably the case because some containers are templates while others aren't. It seems like vector is a vector angled brackets T because it is a template. It's like, I mean, I guess you just call it a class template, but it's a container class template or just a container template, but I think it's a container class template because it has predetermined functionality. So I'm assuming these containers are probably classes. Okay, so some aren't changeable, like a string isn't going to be a set of integers, it's going to be a set of characters, whereas other ones might be chosen like integer x and then the brackets to become an array, a C-style array. Yeah, that way I can have an array of structs that are custom. Yeah, that would be cool if I could create separate yeah. Yep. Yeah, it is a class template. Yeah, makes sense. Yep. And then getting and setting, you just, I guess, need to be careful about what it actually is. But maybe the instantiations can become specializations where instead of instantiating them, you actually create the definition for the specific type. That way you can do more with it. Meaning, if I have a regular vector, maybe I want to have specific behavior for a vector of elements of type spell struct. Like maybe I want to get something special for them. But then again, maybe we just get the element and then from there get the element's properties. We don't actually need anything special with the container. Heterogeneous container. Scripting languages. Okay. Containers library. Meaning a class type that defines the container? What do we mean here? Seems like it if we're talking implementation. Are we saying that the class type implements a container, meaning that the class type basically is a container? We use the class type as a container? Only the class types in the containers library. So these specific ones like standard vector and other things are containers in C++. Okay. Container for ones in general amongst different programming languages, or just about what it is in general, but a container class when talking about the specific ones that are implemented in the standard library. Gotcha. Not arrays, not standard strings, and still not standard vector, but specifically for a Boolean. Why? Because that's, I mean, it seems like that's an array. That's just like a binary integer, right? It must implement all of these features, and what standard vector just bool doesn't. Include the implementation of certain member functions. So why? Is it because standard vector bool as the template type is a specialization that's already made that doesn't have certain member functions? That makes sense. Standard string and standard vector implement most. Pseudo container, okay. Standard vector and standard array. I wonder how they're different. The most common, okay. The others are specialized, okay. Oh, here we go, arrays, nice. Contiguously, oh, gotcha, whereas what? Standard vector or other types don't necessarily take up the same block in memory. Like for example, if I want to run windorstat, this like stat program, or this this diagnostic storage tool for Windows, you open it up and it opens up a big rectangle of all the space in your computer. And there are a bunch of different rectangles. Some are huge, some are very small, some are split up, some are huge and it's all one color, some are the same color but they're split. Meaning that you might have a vector that uses a piece of memory here and a piece here and a piece here and a piece here, and it seems like it's a linked list basically, where you have a list of items, but at the end of the list is a pointer to another piece. That way, let's say you have you have memory that is that has random filled pieces, occupied pieces. Well, and you have a big array, you can't just drop it in there because it's going to be overlapping used pieces of memory. But you could find the pieces that are empty and use them and join them together. Okay. But an array is one that doesn't do that. That is all contiguous where the memory is next to each other. Placed in an adjacent memory location. So we could access one with its address and then add one allegedly, or add maybe a few to get the next one. Okay. Directly access them. The first choice. 3 primary types. C style, so that's probably inherited from C. And then standard vector is also an array. And then standard array is also different. I don't know how those two are different though, it's curious. C style were indeed inherited. Like fundamental types, okay. Arrays, but in modern types they're called C arrays or C style arrays. Okay. They're also called naked arrays, fixed size arrays, fixed arrays, or built-in arrays. Maybe because they don't implement, they don't have member functions, they aren't a class maybe. They're just this inherited fundamental type. Just like there's no int.length, you'd have to get a header file to, or size of or something. Int doesn't just come with size of. there's a function called size of defined elsewhere that you have to include to then do size of. See style array. And use array when talking about them in general. Behave strangely and they're dangerous. Probably for the same reason that pointers can be dangerous, where you can easily assign it to be something else and access a place in memory where you don't want. But maybe for arrays it's even more dangerous, because all you have to do is try and access it and do just the wrong index, especially if you're like looping through. And I access one, and then I add one to the memory location we're accessing to get to the next one. And I add one, add one, add one. Oh, and I overstepped and fell off. I think that's a segmentation fault, where you're accessing memory that you're not supposed to. But it seems like that's probably also the same as just undefined behavior, but maybe not. Standard vector was made, and then standard array was made even later. Interesting. Oh, okay. Standard vector was added. Most flexible. Okay. Direct replacement. It's more limited, but can be better. Okay. More efficient for smaller. Okay. More safety stuff built in standard vector. Okay. Damn, dude. Gotta wait a while. Hopefully not more than 7 more minutes. I gotta go to the bathroom. Standard vector. At the top of the screen, meaning, oh no, we have 30 different objects and we have to name each one differently. Kill me. Damn. Okay. Okay. Makes sense. Container classes when we're talking about ones that are specifically implemented in the library, whereas classes in general, or containers in general, is just the topic of an object that stores a list of other, or a sequence of other objects, or of objects that are the same type of each other. Container classes, the standard library container classes. Array in general for all array types. Okay. Standard vector because standard vector is implemented in other programming languages, or the type of vector, and it's also implemented here? Or meaning that arrays and container classes both describe standard vector? Oh, it does, because standard vector is an array, but it's also an array specifically implemented in the standard library as a container class. Okay. Oh, good. Let's open up the phone. guess there's just no... no feedback for opening up a hotspot. Okie doke. A list constructor, so it's a type of class, and we pass it stuff differently. Do we have to loop it? I'm not sure how we initialize it. Man, I'm a fucking retard. I went way too early. Oh, I'm good. I'm saved. Oh no. Guys, way too early, bro. Yep. Makes sense. Value initializing, sure. Contains 0 elements, not even one. Not one initialized to 0, actually no elements. So 1 element 3. Man, I'm tripping now. Oh, duh. We're specifying the type. So it can do class template argument deduction, or we can explicitly say it. Okay, that makes sense. What about copy? Where we don't specify this, but we pass in a literal, a standard vector initialized with 3 and 4. Uh-oh. Hold, and one more brace at the end. I think that'll do it. Nice. So there is a copy constructor too. Meaning that we can create it once and then... Well, I mean, apparently destroying and creating objects that are empty doesn't cost anything. It's the assignment of value that is. So maybe it doesn't hurt to just create... Well, I guess empty could be cool, though, because we could check if it's empty. If the length is 0... Yeah, if length is 0, then boom, we're done. No players are left. If all the players are... Each player is an element. Cooking. Yeah, and then dart argument, yeah, CTAD, yep, exactly. That's preferred, so we don't specify. Just because it's redundant. Oh, wait. If we created it and initialized it, is there a way to set it back to not having a type? So then we can initialize it with different elements again later, or I guess assign it because it's already created. Meaning that I can have an index of, or a standard vector of integers, and then clear it, and then add in, fuck it, strings. A standard vector of standard strings. I don't know. Or do I have to destroy it? Excuse me. Yep. So is the constructor going to loop through each one and dynamically create, I don't know how this is going to work. Okay. I wonder what it looks like. Okay. Damn. Oh, is that the point? So there's one data member officially in a standard vector, and it is of type standard initializer list. And we initialize it somehow member-wise, element for element, band for band, with an initializer list that it is taking as a parameter. Name 0, name 1, name 2, name 3. The subscript I mean, okay. A reference to the element. That's cool. Zero based. Oh, gotcha. So this one is 1, 2, 3. We're accessing the memory address and traveling, or accessing the memory address, or the something like that. Accessing this element and traveling this many elements from it to get somewhere else. Yeah. Oh. All right, gotta go.